Hello, everyone. Welcome to Theo-MathProblemSolver. In this particular episode, I'm so excited to take you through the journey of integration by substitution. You see, many integrals are complex and difficult to evaluate in their original form. Okay, so by kind of making an appropriate substitution, the integral can be transformed into a simpler form that is easier to solve. So this technique, leverages the chain rule of differentiation in reverse, allowing for more, straightforward integration. But how do we handle such situations? So when dealing with composite functions, of which we spoke about in the previous episodes, we mentioned that one function is nested inside another. Okay, so integration by substitution is particularly useful, and by substituting a part of the integrand with a new variable, it kind of becomes easy to kind of separate and simplify the nested functions, thereby making the integral more manageable. Okay, I'll take an example and I will kind of will be able going to exploit further. Okay, so stay with me. And at this point, if you have not subscribed, please do so. Like my content, comment, turn on your notification button so that anytime I release new content, you'll be the first to receive that. And as I mentioned, the goal of this platform is to help, demystify the myth around mathematics. All right, so let's keep this good news spreading. Thank you so much. So let's get going. So let me bring out one example, then we can sort of go from there. So the first example. So example one. So as I mentioned, with a integration by substitution, we use the concept of the chain rule. Okay, so the chain rule we kind of applied it, or we deployed in the differentiation. What do we do? That we reverse the process. Okay, so we'll reverse that process. So let's take note of that. Now, suppose I ask you to evaluate the integral of x to the power, write it well, x to the 3x, what is it? 3x to the power 2 and multiplying x to the power 3 plus 1 all to the power 10. You see, if I ask you to, you know, take the integral of this is a bit not straightforward. Unlike the case if I had to give you x to the power, let's say 2, this is easy, right? Because we just have to apply one of the properties of integral and we'll get a result. And we said that increase the power. We said that what? Increase the power by 1, okay? Which make it 3 and divided by the increased power, then we add c. And this is straightforward, right? But this problem that we are given, it's not like this. It's not straightforward. So we have to apply an appropriate technique, in order to solve such a problem. And that is why in this problem, I'm going to use a technique that we call integration by substitution. Is that okay? Very important. So let's take note of that. Now, you ask yourself that, so there are two functions, okay? One is 3x to the power 2, and then what we are going to look at is just the base of this, okay? The base of this particular function, which is x to the power 3 plus 1. Now we see that one of them happens to be, the differential of the other, right? For example, if we should differentiate x to the power 3 plus 1, we get 3x squared. Do you see that when we differentiate that? So it means that we have to do something about this. Okay, so what we are going to do is that we will say that, so solution. So what we'll do is that we will say that we will say let u, okay, let u to be equal to x to the power 3 plus 1. And why do we do so? Because when we differentiate this, when we differentiate x to the power 3 plus 1, we get the 3x squared, okay? So you always have to think about it. Think about it this way, that so we have two functions. Now, which of them is the differential of the other? Okay, you always have to think that way. That is the first step. The first step is that which of the function is the differential of the other, and it's always it's always the best way to look at it that way. Okay. Now, what is du? So it means that our du will be what? 3x squared. Is that okay? Dx. Now, because we have our du this in this form, what we are going to do is that if I were you, I would rather transform this function to fit this. Okay. So if I were you, I would transform this integral to represent or to look like this. Okay. So how, and the reason why we are doing that is because of this result. We want the result, we want the integral to have this term, okay, in it, okay? So that we can do substitution, because we've already let you to be this, okay? Now with that, what we are going to do is that, what we are going to kind of do is that, now our integral, remember, now our u is this, right? So which means that you're going to have the integral of what? Of u. Remember, this one has been represented as u. So we're going to have u to the power what? U to the power 10, okay? And what is 3xd? 3x dx, 3x dx is what? Sorry, here has to be 3x squared, okay? So 3x squared dx can be replaced by what? Du, okay? So this, we have that. Now, what is the integral of this? So we said increase the power by 1, then divided by the increased power. Now over here, what we need to do is we need to do what we call the reverse substitution, okay? So we have to reverse the substitution. And by reversing it, we are going to have what? We're going to have, what is u per the way we started? We said that our u is what? X to the power 3 plus 1. So we have x to the power 3 plus 1 over 11 plus what? Plus the constant c. Okay, so this is the solution to the given problem. I believe we all get that. So let's go to one more example, then, so that we can appreciate it more. So let's go on example 2. So with example 2, let's see. Let me see what I can give you some nice problem. Now, suppose I give you something like this. So you want to evaluate. So we want to evaluate. So we want to evaluate x to the power 3 divided by 5 minus x to the power 4 or to the power 5 dx. Okay. Now, what are we going to do is that, so you ask yourself that which of these two, so we have x to the power 3, let's say x to the power 3 is one function and 5 minus x4 or to the power 5 as one function. So we ask ourselves some basic questions that, so usually what we do is that we look at the base of the other function, okay? Or the second function. So we see that one of them is a differential of the other, okay? So when in this case, what we are going to do is that, so solution, in this case, what we are going to do, we're going to let u to be equal to 5 minus what? X to the power 4, okay? Then our du will be what? Minus what? 4x to the power what? 3. Is that okay? Dx. Now, at this point, what we want to do is that let's try and rewrite this because of what the result we just got. So what we can do is that we can, because we have -4 here, what we can basically do is that we can multiply the whole of this. We also want to cancel the -4 here. So we can multiply this sum by minus of 1/4, okay? Okay, because we want to take care of that. So we want to do that so that we can have the, or another easiest way is that we can, isolate, because we see that we have x to the power 3 multiplying the x here, we can also isolate. So we can isolate this, okay? We can isolate so that we have this. So in which case this we can just write this as what? As 1 over 5 minus 4, 5 minus x to the power 4, or that's multiplying x to the power 3 dx, okay? Which means that wherever I see x to the power 3 dx, I just have to replace it by the whole of this one. Is that okay? Very important. So let's take note. So which means that my integral of what? 1 over, and we know that this is your u, right? So we're going to have what? U to the power what? 5. And so this is the same as what? Is what? Du minus du on 4. Is that okay? And this, when we simplify this a bit, we're going to can pull out -4 out. Then we have what? 1 over u to the power 5 du. Is that okay? Now let's simplify this. And this can be written as what? U to the power what? -5 du. Okay, now let's simplify this. So this, we're going to have what? So we add 1 to the -5, and that gives us what? -4 divided by the -4. Okay, so with that, we're going to have 1 over 16, then the u, then we can reverse that, okay? By rewriting backwards, we're going to have u to the power 4. Okay, now we have to reverse the substitution, because remember, the solution has to be in terms of x. So we have to do a reverse, what we call the reverse or substitution. Okay, so we do a reverse substitution. But note that our u initial was what? Our u, what we did, we made our u to be equal to what? We made our u to be equal to 5 minus what? X to the power what? 4, right? Let's see. To the power 4. So with that, if that's the case, then our result will be equal to what? 16. Our result of the integral of 1 over to be equal to what? 16 multiplying 16, what? And our u is what? 5 minus what? 5 minus x to the power that. Okay, so this is going to be our result plus a constant c. Over here, we need to add a constant c. So let's take note. Okay, very important. So let's take note. And at this point, if you have not subscribed, please turn on your notification button so that anytime I release new content, you'll be the first to receive that. Is that okay? Very important. So let's look at another interesting problem. And it's an example that I like it so much. So let's try it and see how best we can, evaluate that. So how do we evaluate this particular problem? Okay, how do we do that? So you ask yourself some questions, okay? This is so this what do we do? So what do we let u to be? So you can let u to be equal to what? 4x minus what? 8x what squared. So on that note, your du will be what? Will be what? Minus what? 16x. Is that okay? Will be minus 16x or dx. Okay? So what we want to kind of do is that we want our since it's as if we can do something here. You see, we have x here. So let's point out you have x and we have the x here, of which they are here. So, okay. So what you can be, you want to separate that. So you want to separate us, which means that we're going to have du on what 16 to be equal to what x dx. So that anytime we get here, we can just plug in. So what we do is that we can also rewrite this by rewriting it. We're going to have sine of 4 minus 8x squared or x dx. Okay. So since we have that, it just kind of makes sense that we kind of also utilize that. Okay. So by doing that, which implies that our integral, so our integral for sine of what? Remember, we let this to be u. Okay, sine of u. And what is x dx? X dx should be replaced by this quantity. Okay. So we're going to have our du on minus what? 16. Okay. So this will give us what? Minus, we can pull out the minus 16 out. Then we have sine u du. What function do we differentiate to get sine u? And that will be what? Minus what? Cosine of what? U. Is that okay? We add a constant c. And since this is just a definite integral, we need to add a constant. And the reason why we add a constant is that we may not know whether the original function had a constant on it, okay? And that's why we add that. And we also said that the solution of the indefinite integral is not unique. It has family of solution because c is arbitrary constant. C can be any constant, okay? Take note. Now at this point, we need to also do a reverse substitution. And by doing our reverse, our u was what? Our u was originally what? 4 minus 8x squared. So 4 minus 8x squared plus c. Okay. So that's a result of this interesting problem of the day. And at this point, if you have not subscribed, please do so. Like my content, comment, and let's see how best we can help demystify the myth around mathematics. Okay. All right, so let's go at one more example under this. So one more example. So this should be example what? Example 4. This should be example 4. So how do we kind of evaluate this definite integral? How do we evaluate this definite integral? How do we do that? Now you ask yourself some basic questions that which of the two functions, sometimes with this type of problem, what we do is that e to the some exponent, usually we look at the exponent of what? Of e, okay? we see that the exponent of e is x to the power 4, okay? And when we look at this here, we can relate to that, okay? Because when you differentiate x to the power 4, we get what? 3x to the power 4x to the power 3, of which we can do something about it, right? So let's take note of that. Very, very, very important. All right, so what we want to do is that what we kind of want to do is that we can pull out, we can sort of pull out we can pull out something, but I can kind of let's just get straight to the point so that I don't want to waste my time on this. So I can just say that let x to be equal u to be equal to what? X to the power 4, right? Which means my du will be what? 4x to the power 3 dx. But you see that we have x to the power 3 dx here. So which means this one we can rearrange this to fit what we have here, okay? So what we do is that over here is that we're going to have the u or no, the 4 equal to x to the power 3 dx, which would enable us to rewrite this particular problem in this nice structure, okay? Or what you can also pull out the 28 outside. Okay, so we can put it outside, then we have e to the power x to the power 4, then x to the power cube dx. Okay, so once we have this, then now the situation becomes easy, right? Our situation is easy. And over here, we could have done something, but I didn't want us to worry so much on that. So since now, you see, now since we are changing everything in terms of u, you may also want, now we have a limit. Remember, the limit has to do with x, so we can also do something nice over here. So what we'll do is that when you see that when x is 0, I'm talking about the lower limit, what do you get for u? Remember, u is here. So what do you get for u? When x is 0, we have u to be what? 0. And when x is equal to 1, our u will be what? Will also be 1. Okay? Instead of how we instead of probably solving this, then the final we do a reverse, then we solve it back. We may want to do it straight away like that, okay? I'll explain as we move on. So it means that over here we can just replace the x to the power 3 dx by this particular quantity, okay? So with that being said, we can just go straight to the point. So we have 28 and we have e to the power what? E to the power u and x to the power 3 dx is the same as what? Is the same as du on 4. So with that, we're going to have what? We're going to have 28 on the 28 on 4. What is 28 on 4? And that is what? That is 7, right? So that is 7. So we have 7. All right. So let's move on. So what's the integral of the exponential function of the the simple exponential function, which is itself? It's always itself. Oh, is that okay? So we're going to plug in that minus e to the power that, and that should give us what? 7 e minus what? E to the power 0 is what? Is 1. So we have this as our result. Is that okay? So over here, remember, we didn't do a reverse substitution because we have already taken into account the limit of x over here. And that is why we didn't take into account of the reverse substitution. And at this point, if you have not subscribed, please do so. Like my comment, like my content, share this content with your colleagues, with your loved ones, and turn on your notification button so that anytime I release new content, you'll be the first to receive that. So let's look at another interesting problem and see how best we can solve that. I'm trying to, look for a more maybe complex one for you. So let's try this problem. The last problem, I guess, the last problem, then we can, play with it. Okay, let me bring out some problem for us to solve it and see. So what if I give you this to evaluate? So if I ask you to evaluate the natural log of 3x on x dx. If I ask you to evaluate this, what do we do? Now what we're going to do is that so over here, let u to be what? So we can let u to be 3x. Then our du, so this implies that our du will be what? Will be 3 dx. Is that okay? Our du will be 3 dx. Is that right? But would this really help us? This that can we if we do this, would that help us? Hmm. Would that help us? Anyone? So we see that this approach may not work. Okay. And the reason is simple. It's because when we do it this way, we may not have anything to cancel. And remember, the whole point of substitution is to make sure that the problem becomes easier to solve. But this approach will not work, okay? So you will not let u to be just 3x. So what we'll do is that we'll say that let u to be what? To be the whole of the length of the natural log of what? Of 3x, okay? And what is the differential of the natural log? Remember, with the differential of the natural log, what happens if we differentiate the input? And that is what? 3. Then we divide it by the what? By the input. Okay? So we differentiate the input, that is what? 3, and divided by the input. So we get what? 1 out of x dx here. Okay? Is that okay? And this is the same as what? The x on what? On x. So if I were you, what I do is that I would just have to arrange this so that if it fits this, okay? So this one we're going to have the x on x, okay? So that wherever we see the x on x, we just replace it by du. Is that okay? Very good. So with that, what happened is that we're going to have the integral of the natural log of what? No. So we're going to have, remember, we have let the whole of this to be that, okay? So we are going to have, let me use different pens. So we have of u, and what is this? This is what our du. Is that okay? Our the x on x is our du. And what is the differential? So what's the integral of this? The integral of this is what? U to the power 2 on 2 plus a constant c. Now over here we have to reverse the process. What is u? Our u was what? Length of 3x. then we need to square that, right? Or divided by 2 plus what? Plus a constant c. Is that okay? Does that make sense? Does this make sense? All right. And at this point, if you have not subscribed, please do so. Like my content, spread this content with your colleagues, with your loved ones, and let's help, demystify the myth around mathematics. Stay blessed.